This is lesson 1.1 out of the Rates, Ratios, and Statistics book. In my class, 1.1 starts on page 98, and lesson 1.1 is titled simply Ratios. All right, so this lesson takes in quite a bit of new information. Some of it will be somewhat familiar for most of my sixth graders from some things you did at the end of your fifth grade, but it typically is information that feels pretty new to most of you. So going to be a lot of notes in this one. There's just no way I could really make it simpler. All right, so here we go with warm-ups. And I have a stuffy nose right now, so I just need to apologize for voice quality here, but seems to be the way it goes sometimes. All right, here we go. Warm-ups. Simplify simplify each fraction write your answers as a proper fraction or improper fraction. Write your answer as a proper or improper fraction. Not mixed number. So the reason they're having you do this as a warm-up is part of writing ratios is writing them in a way that looks like a fraction, but it isn't really. We know that fractions are something that compares a part to a whole. In a ratio, you might be comparing a part to a whole, or you might be comparing a part to a part. And so we don't convert the fractions into mixed numbers ever. They're either a proper fraction or an improper fraction if we are writing them as a fraction, as what looks like a fraction. But there are other ways to write a ratio, and we'll be learning about that in this lesson. But I just wanted you to know why they were doing this. Usually when we're talking about fractions, we don't do this. We do put it into a mixed number if it's an improper fraction. But right now, you are not going to. All right, so the first one is 10 over 15. Second one, 16 over 40. Third one, 14 over 7. Fourth one, 48 over 36. So let's just get a little bit of practice in how to simplify fractions. All right, so our I can statement for this lesson is I can simplify and write ratios three ways. There are three different ways to write ratios, and we'll be learning that in this lesson. Okay, so with my dark green pencil, I'll underline here, and then we'll get ready to make our notes. All right, so I have two sets of glue-in notes. We'll put them in the upper right, one right under the other, with the vocabulary one first and the writing ratio one underneath the vocabulary. So if you don't want to watch me glue these on, you can slide forward a little bit to where I am done with this part and pick up with the lesson. Okay, so both my little note slips are glued down, and get my highlighters out, and we'll talk first about the vocabulary. So vocabulary. Vocabulary we'll be talking about is ratio. Okay, so what is a ratio? A ratio is a comparison of two numbers using division, right? You'll see what that means. That sounds a lot like a fraction, I know, but it's a comparison, not necessarily actual division. You'll see what I mean in a little bit. All right, so good to know. Here are the things that we will be learning about here. The good to knows are, first, a ratio shows a part to another part or a part to a whole. You'll see examples of that. A ratio written as a fraction should be written in simplest form. Just like we've always said when we're writing fractions, fractions need to be simplified always. A ratio can be larger than 1. That would mean if you were showing it in the fraction form that it would be an improper fraction. If the numerator is larger than the denominator, the number is larger than 1. And you can remember that from when you had to convert that into a mixed number. You would have some whole number plus a fraction. That means your fraction is larger than 1. All right, so ratios larger than 1 should be written as simplified improper fractions. So that gets us back to when it's the numerator is larger than the denominator, we don't turn it into a mixed number. All right, so ratios can be larger than 1. I'm going to put with my yellow pen, or actually I'm going to back up a little bit. And with my red pencil, I'm going to write a ratio written as a fraction should be written in simplest form. So fraction, simplest form, always. Ratios can be larger than 1. That means that it will be an improper fraction. Appear to be. Ratios larger than 1 should be written as a simplified improper fraction. We keep it as an improper fraction. Don't turn to mixed number. Oh, my glue's kind of wet there. I'll have to come back to this. Mixed number. I can't write on there right now. All right, so that's our vocab for this lesson. Let's talk about writing ratios. All right, so when we're writing ratios, a ratio comparing two numbers, say for example 3 and 5, can be written in 3 different ways. All right, so the first way is as a fraction. So the ratio of 3 and 5 can be written as 3 to 5. All right. It can also be written using a colon, and this is usually how people see a ratio written. The colon means the word 2, 3 to 5. You can also write it just simply using the word 2. So a fraction can be written as, if I got that in frame, here we go. Yeah. All right, a fraction can be written as 3 to 5 using the word 2. So any of these 3 ways of writing a ratio, did I say a fraction can be written as 3 to 5? Sorry. Ratio. A ratio can be written any of these 3 ways, and they're all valid. Now, in your assignment during this, because we're getting practice at getting familiar with them, you will be asked to write them in specific ways. Sometimes all 3 ways, or sometimes it will specifically tell you to write it, your ratio with as a fraction, or with the colon, or with the word 2. So pay attention to that. All right, so let's take a look at how we work with these ratios then. So my first example I want to do, I'm going to write it right up here, is Paul picked a handful of jelly beans. All right, so he just scooped out a random handful of jelly beans out of a jar. All right, he chose 8 blue, 4 green, 2 pink, and 2 yellow. All right? That's the combination of things that he did. So I'm going to make this stand out a little bit, and we're going to highlight with our blue highlighter that there were 8 blue, and there were 4 green, 2 pink, and 2 yellow. All right? So that's the combination of jelly bean colors that Paul got. All right, so what we're going to do then is write a ratio using each of the 3 ways. All right, so A, compare blue beans to pink beans. All right, so how do we do that? All right, well, if I'm going to do that, let's say in the fraction form, I know that there are 8 blue beans, right? So I'm going to put 8 here, and I'm comparing that to the pink beans. I don't have a pink pencil, so I'm going to have to use the red pencil. We'll pretend it's pink. All right, to 2 pink ones. All right, now remember back here, where did it say? Yes, a ratio written as a fraction should be written in simplest form, always. Is this simplest form? No, it is not. We are not going to turn it into a mixed number. We're going to keep it as an improper fraction, but we're going to simplify it. All right, so I know that 2 goes into itself once. All right, so I'm going to go ahead and do this. So 2 goes into itself once, and 2 goes into 8 4 times. So my ratio of blue beans to pink beans is 4 to 1. All right. I can also write that as 4 to 1, or I can write that as 4 to 1. All right. Okay. That's our first way of showing in the 3 different ways the ratio of blue beans to pink beans in all of the jelly beans that he grabbed out of the jar. Okay? All right, now let's look at another example. B. Compare green beans, green jelly beans, to the total number of beans, jelly beans. All right, so the total number, we have 8, 12, 14, 16 beans total. Okay, that's our total number of beans in the handful of beans that he pulled out of the jar. So our total number, we're comparing the green to the total number. So our total number is 16. And how many green beans did he wind up with? 4. All right, now in this form, we have to reduce or simplify. Okay, so 4 can go into itself 1 time. And then 4 goes into 16 4 times. So the ratio of green beans to the total number of beans he pulled out in his handful is 1 to 4. So we can write that as 1 to 4. We can also write that as 1 to 4 with the word 4. Right? Okay, so one more look at this. C. Compare pink beans to the total number of beans. So just like the last one, only now we're comparing the pink beans to the total numbers, not the green ones. Total number of beans. Excuse me. All right, so we already counted up the total number of beans. We know we have 16, right? So 16. Well, how many pink jelly beans were there? There were 2. All right, and I'll get my red pencils. I don't have pink. So there were 2. Okay, that is not simplified. I need to do that. So I know 2 can go into itself once, and 2 can go into 16 8 times. So the ratio of pink beans to the total number of beans is 1 to 8. And I can write that in 2 other ways. 1 to 8, or 1 to 8. Right? So those are the 3 different ways that we can write a ratio based on this information we had here. There was our problem, and then there was our situation, and then here are the 3 different ways they wanted you to think about the combinations, the ratios that we had, and write them in all 3 of the ways that we know we can write ratios. Okay, so that's the first page of our notes here. Let's see if I probably can't get them all in. So there's the top part and the bottom part. Okay, so now let's see how these ratios are used in word problems in real life situations. Okay, so we're on page 99. This is our second page of notes for lesson 1.1. And we have 2 situations, two problems we're going to deal with, 2 situations that we are going to work with in finding ratios in several different ways. So the first one is Petra is filling jars with marbles. The jar sizes change, but the ratio of blue marbles to green marbles is always the same. Right? So we're going to draw a little chart here that represents these jars of marbles that Petra is filling. So she has blue marbles and she has green marbles, and she has 5 jars. So 1, 2, 3, 4, 5. 5 different jars. Okay. All right, so she has blue marbles and she has green marbles. And she has 5 jars, so I'm just going to write J1 for jar 1, J2, J3, J4, and J5. All right, there's her 5 different jars. Well, in jar 1, she has 6 blue marbles and 10 green marbles. In jar 2, she has 12 blue and 20 green. In jar 3, she has 18 blue and 30 green. In jar 4, she has 27 blue and 45 green. In jar 5, she has 33 blue ones. And I'm not going to tell you how many green ones she has in jar 5 right now. We're going to work that one out a little bit later. All right? Okay, so here's the scenario. Now, here's where we work at finding some ratios. So, A. find the ratio of blue to green. Okay, we're going to find the ratio of blue to green, and that would mean for any jar, because remember she said that the ratio of blue to green marbles is always the same. So because it's always the same, no matter which jar we're talking about, we could choose the number of blues to the number of greens in any jar and find the ratio. I'm going to choose the numbers in jar 1 just because that's where they're the smallest, and so the smaller numbers are easier to work with. All right, so there are 6 blue marbles and 10 green marbles in jar 1. So the ratio is the simplified, this fraction, this ratio, simplified. So I know that 2 can go into 6 3 times. 2 times 3 is 6. And 3, I mean. 2 can go into 6. 2 can go into 6 3 times. And 2 can go into 10 5 times. So the ratio is 3 to 5. So I'm going to write that here. Ratio is, and I'm going to write it with the colon. It would have been fine to write it as a fraction or write it as with the word 2. I just prefer the colon for ratios. So the ratio is 3 to 5. Now, let's make a little note here so we know what we were talking about. You could have used any of the jars and simplified. As long as you have it simplified all the way down to until it can't be simplified anymore, no matter which jar you started with, you would wind up with the ratio. So again, I just chose the one with the smaller numbers, easier to work with. Okay, so now B. Find the number of green marbles when there are 33 blue marbles. So here's where we figure out how many green marbles are in jar 5. All right. Okay, well, I start with the ratio. I know that the ratio is 3 to 5. So I'm going to write 3 to 5 equals, okay, there are 3 blue marbles for every 5 green marbles. All right, that's what that means. So that means if I know that there are 33 blue marbles, actually, I think I'll write that in blue. Makes sense. I know that there are 33 blue marbles. Well, this is the same as when we were working with fractions and we learned how to make equivalent fractions. All right. What did I have to do to the 3 to get it to a 33? Well, I had to multiply the 3 times 11 to get 33. And what you do to the top, you have to do to the bottom. So I'm going to multiply 5 times 11 to get me my number of green marbles. And 5 times 11 is 55. Right? So 55 is what should be in that box there. Right? It's the same as when we were making equivalent fractions. Okay? We build them up or we break them down to simplify. All right, so that's all with Petra's jars of marbles. Let's look at another problem. Okay, the next one is, let's see, start here. This is a common problem you'll see in ratios. The ratio of boys to girls in a class is 5 to 9. All right, 5 to 9. Okay, so A. What is the ratio of girls to all students? No, I'm going to put that on the next line. Hold on. The ratio, what is the ratio of girls to all students in the class? All right. Okay, so the ratio of girls to all students in the class. Well, there are 9 girls in the class. What's the total number in the class? 9 plus 5 is 14. So 9 to 14. Or you could write 9 to 14, right? That's the ratio of girls to all the students in the class. Now, what if we were to ask the same question, but this time it's the ratio of boys to all the students in the same class, right? Which is exactly what we are going to do next. So B, what is the ratio of boys to all students in the class? Okay, now we're talking about the ratio of boys to the total number of students. So how many boys were in this class? 5. And the total number was 14. This cannot be simplified any further, neither could the 9 to 14. So I could also write this as, whoops, not 9. How many boys to the total in the class? 5 to 14. All right? So that's the 2 different ratios that we could talk about. We already knew what the ratio was for boys to girls, so now we talked about the ratio of girls to all the students in the class and the ratio of boys to all the students in the class. Okay? Now, one last question on this one. C. I'm going to skip a line here. All right. What does the class ratio mean? And you've heard me talk about this, okay? But you'll see this question a lot in your worksheets, and probably even on your test. This is where you explain in words what this ratio means. So, what does the class ratio mean? That means the original question up there. The class ratio means that for every 5 boys in the class, for every 5 boys in the class, there are 9 girls. So when you're asked this kind of question, what does the class ratio mean? What they're asking you is to explain in words what those numbers actually mean. For every 5 boys in the class, there are 9 girls. Okay, so that's the notes. Let's take a look at some practice problems. All right, so practice problems for lesson 1.1. The first one is simply to write each of these, making sure you're showing them in all 3 ways. So they're showing this with the 2, write the other 2 ways. They're showing this as a fraction, write the other 2 ways. They're showing this with the colon, write the other 2 ways. Okay. Number 2. All right, so there are 7 girls and 8 boys in the class. We did one in our notes, very similar to this. Write the ratio of boys to girls, write the ratio of girls to class total, and write the ratio of boys to class total. All right. Number 3. Julio asked several students what type of movie they preferred. So this is somewhat similar to the chart that we did in our notes with the marbles, all right? So this row is the type of movie, and this row is the number of students who said they preferred that type of movie. So when he asked all these students, 25 of them said comedy, 20 said drama, 40 said action, 10 said adventure, and 5 said cartoons. So the questions then ask you, write a ratio for the number of students who prefer comedy to those who prefer action. Comedy to action. All right. Find the total number of students interviewed. Okay, that would be all the D's. How many did he interview? Now, write a ratio for the number of students who preferred each type to the total number of students. So you'll be writing 5 ratios. All right. Okay, so I'm going to put it back to the top, give you a chance to pause. And let's see how we do these problems. All right, so simplify each ratio and write each as a fraction with a colon and using the word to. All right, so this one is 5 over 20, 5 to 20. Okay, 5 to 20. So that would be simplified as 5 goes into itself once and 5 goes into 20 4 times. So the ratio is 1 to 4. And then that would be written as 1 to 4. And also as 1 to 4. Right? There's all of the 3 ways. All right, this needs to be simplified. So I'm going to say 10 goes into itself once and 10 goes into 110 times. So that can be written as 10 to 1 or 10 to 1. Right? All right, this is 9 over 9, which can be simplified to 1 over 1. Now, in this case, we do not turn that into a 1. I know you want to do that. That's the kind of simplifying that we're used to seeing. But this is a ratio, 1 to 1, a 1 to 1 ratio. So for every 1, there is a 1 of whatever we're comparing here. So that can also be written as 1 to 1 or 1 to 1. All right? Okay, so number 2. Here's where we have the classroom of kids. There are 7 girls and 8 boys in the class. Write a ratio of girls to boys. Okay, so there's 7 girls to 8 boys. All right? And I cannot simplify that any further, so that's just how it is. Now, write the ratio of girls to the class total. Well, 7 plus 8 is 15. That's the class total, and the number of girls is 7, and 7 over 15 cannot be simplified, so the ratio of girls to the total in the class is 7 to 15. Now write the ratio of boys to the class total. So that would be, we know the class total is 15, we figured that out already, and there are 8 boys in the class. That cannot be simplified, so the ratio of boys to the class total is 8 to 15. Okay, and the last problem, number 3. All right, so, Julio asked several students what type of movie they preferred. All right, so then we have a table here that Julio made after he interviewed all of these students. All right, so the first one, it says, write a ratio for the number of students who prefer comedy to those who prefer action. All right, so comedy is 25 to action 40. And this can be simplified. How do we simplify that? Well, 5 goes into 25 5 times, and 5 goes into 40 8 times. So the ratio of students who preferred comedy to those who preferred action is 5 to 8. So for every 5 students who preferred comedy, 8 students preferred action movies. All right? Okay, so the next one is find the total number of students interviewed. If I remember right, I added this all up. I think it was 100. Over 4. Yeah, I think that's right. Okay, so there's 100 total. All right, so now write a ratio for the number of students who prefer each type to the total students. All right, so comedy, that's 25 over 100, which equals 1 to 4. All right, so 1 to 4 is comedy. All right. Drama, that's 20 over 100, which simplifies to 1 over 5. So the ratio that prefer drama is 1 to 5. And action, that's 40 to 100. And let's see, so 40, 20, okay? 20 goes into 40 2 times, and 20 goes into 100 5 times. So the ratio of those who prefer action is 2 to 5. And then adventure, that's 10 over 100. So 10 goes into itself once, 10 goes into 100 10 times. So the ratio of those who preferred adventure is 1 to 10. And then the last one is we have 5 over 100. And 5 goes into itself once, 5 goes into 120. So the ratio of those who liked cartoons was only 1 to every 20. All right? Okay, so that's how we figure out ratios for things like that. Let's take a look at your worksheet. Worksheet is very similar to what we did in our notes and practice problems. So this top part here is simply write each ratio as a fraction in its simplest form. Let's underwrite that. It's saying to write it as a fraction in its simplest form. It's not asking you to do it in all 3 ways. It's just saying whatever you see here, write it as a fraction and make sure that it's in its simplest form. Now on this one, it says simplify each ratio and write each ratio as a fraction, a colon, and using the word to make sure they're simplified. All right. Okay, and then 9 and 10. 9 and 10, so there's ratios just like what we did in our notes, very similar. You're writing, you're comparing hats to hats, or hats to the total, or birds visited to the total number of birds. Okay, just pay attention to what it's saying, what it's asking you. And then number 11 is very similar to the marbles one we did in our notes. So just take a look at what you're doing there. And then number 12, very similar to the students in a class that we did. All right. So you should be well prepared for those. That leaves us with the exit ticket. Exit ticket here is for lesson 1.1. As always, this is just for extra practice. I don't give you the answers or show you how to do these. Okay, so that's lesson 1.1 out of the Rates, Ratios, and Statistics book. Remember, the only way to learn math is to do math, and mistakes are proof that you're learning.